Let's talk about the mole, what it is, what it isn't, what it can do, and how to find quantities with the mole so we can do some chemistry. What is the mole? In definition, is the amount of pure substance containing the same number of chemical units as there are atoms in exactly 12 grams of carbon-12, the isotope carbon-12. Carbon-12, ever since nearly the middle of the 20th century, has been the standard we use to set our periodic table masses. So a mole of any element is equivalent to its mass in grams appearing on the periodic table. What about this number 6.02 times 10 to the 23rd? Well, it's not knowing to honor Amedeo Avogadro, who in 1811 postulated the hypothesis that equal volumes of gases at the same temperature and pressure have equal numbers of molecules. All of our chemical measurements are based on this, including our periodic table masses. The number is the measured number of atoms or molecules in a mole of substance, and this number has been known since about the beginning of the 20th century. Avogadro did not discover that number. He did not know what the number was. And when we surveyed a number of professors and textbooks, we found that it is rarely used in real science work. Well, you may, however, be asked to solve problems with this number on tests, so you need to know how to do that. To convert from moles to grams, then, you would multiply by the conversion factor, 6.02 times 10 to the 23rd grams per mole. And to convert from grams to moles, you would divide by the conversion factor, 6.02 times 10 to the 23rd grams per mole. Let's practice this rarely used skill. How many molecules are in 3.5 moles of bromine liquid? Well, we simply multiply 3.5 moles by the conversion factor that you see on the screen, and we get 21 times 10 to the 23rd molecules, which in scientific notation is 2.1 times 10 to the 24th molecules. Let's go in the other direction. How many moles are in 1.8 times 10 to the 25th molecules? Well, we do something similar, but here we divide the number of molecules by 6.02 times 10 to the 23rd molecules per mole, and we get 0.30 times 10 to the 2 moles, which in scientific notation is 3.0 times 10 to the 1 moles. And we could simply convert this to 30 moles with 2 significant digits since we had 2 digits in our given. Now, this skill is not terribly important, but you must know it. It's required by the AP. It's required in the TEKS. Moles, however, the concept is very, very useful. Maybe the most useful thing in chemical stoichiometry. So consider this problem. How many grams of oxygen are needed to react with 240 grams of solid carbon if you're forming carbon dioxide? This is a very difficult problem without the mole, because there's no conversion table of grams of reactant to grams of product anywhere. There are just too many chemical reactions to have such a table. It would take up gigabytes of memory. But we do know that carbon dioxide is CO2, so think how many moles of O2 are needed for 1 mole of C. Well, obviously, 1 mole of carbon needs 1 mole of O2 to make CO2. And so the mole relationship is very important. So let's look at the method for going from moles to grams or millimoles to milligrams. You know to look to the periodic table for molar masses. So if you know the moles and need grams and know the formula of the substance, the first thing you do is determine the molar mass of the substance. Then you'll multiply the number of known moles by the molar mass conversion factor. And this formula is given on the bottom of the page. The mass in grams is equal to the number of moles that are given times the grams per mole. So let's practice this very useful skill. What's the mass of 0.356 moles of the amino acid tyrosine, C9H11NO3. Well, the molar mass requires 9 carbons, 11 hydrogens, 1 nitrogen, and 3 oxygens. We look up the periodic table mass and we see 9 times 12 plus 11 times 1 plus 1 times 14 plus 3 times 16 grams. That would be the molar mass. And that's 181 grams per mole. We now go to the problem. The mass of 0.356 moles is equal to 0.356 moles times 181 grams per mole, or 64.4 grams. When we use the mole, things get a lot simpler. All right, what's the mass of 14.2 millimoles of silver nitrate, AgNO3? Well, the millimolar mass is 1 millimolar mass of silver plus 1 of nitrogen plus 3 of oxygen. The mass on the periodic table is either grams per mole or milligrams per millimole. We see that that's 1 times 108 plus 1 times 14 plus 3 times 16, or 170 milligrams per millimole. We then go to the problem and find the mass of 14.2 millimoles must be 14.2 millimoles times 170 milligrams per millimole, or 2,414 milligrams, which of course is 2.41 grams. Now, going from grams to moles or milligrams to millimoles, or for that matter, kilograms to kilomoles, is very easy. We look to the periodic table for molar masses. If we know the grams and need moles, or any other conversion, with the formula we can determine the molar mass. Then we divide the number of known grams by the molar mass conversion factor. So the chemical amount in moles is equal to the grams times 1 mole divided by the molar mass of that substance. Probably a little easier to look at an example. So let's practice. How many moles are in 75.5 grams of sodium sulfate? You see the answer at the bottom. We'll work towards that. The molar mass is 2 times sodium, 1 of sulfur, and 4 of oxygen from the periodic table. 2 times 23 plus 1 times 32 plus 4 times 16. But now we're in grams. So 142 grams per mole. And the number of moles then is the given 75.5 grams times the conversion factor 1 mole over 142 grams per mole, or 0.532 moles. Let's try again. How many millimoles are in 3.45 milligrams of ribose, C5H10O5? Molar mass, of course, you need 5 carbons, 10 hydrogens, and 5 oxygens from the periodic table. 5 times 12 plus 10 times 1 plus 5 times 16, now expressed in milligrams. We multiply and add and we get 150 milligrams per millimole. The millimoles contained in 3.45 milligrams would be the 3.45 milligrams times the conversion factor, 1 millimole over 150 milligrams per millimole. And when we do that division, we get 0.023 millimoles, which would be 23 micromoles if you want to stay away from all those zeros after the decimal point. Let's do one more. How many kilomoles are in 1,730 kilograms of lime, calcium oxide, CaO? This could be an industrial application. Kilomolar mass is 1 kilomole of calcium plus 1 kilomole of oxygen, measured in kilograms. Oh, we look to the periodic table again, and we get 40.1 plus 16.0, or 56.1 kilograms per kilomole. We then do the same kind of math we did before. The kilomoles in that amount of calcium oxide is 1,730 kilograms, notice just 3 sig digs, times 1 kilomole per 56.1 kilogram per kilomole, and we get 30.8 kilomoles. And so we can see that no matter what we use, we're going to be able to find any quantity, the kilograms or grams or milligrams, from the molar number or the number of moles from the mass. Now we can get into the mole hole and do our chemistry, and then come out of it to be able to predict how many grams or milligrams or kilograms of reactant or product are involved. We can also get into and out of the mole hole using the fact that at STP, 1 mole of any gas occupies 22.4 liters of space. There will be more on that later, but now you should spend some time practicing these skills that you've been using.